Hello and Assalamualaikum. Good morning to our lecturer for today, which is Professor Madya Dr. Mustafa bin Awang Kecil, and to all of our friends. Lend me your ear for our forum for today, which is tunneling effect in superconductor that will be discussed by our excellent panel. So, with me, Nur Akila binti Syari, as your moderator for today. So, without wasting any time, we'll be introduce you guys about our panels.
Okay. Hello, my name is Nura Atika Adila Mizana. So I'll be your first panel for this forum.
Hi guys, my name is Chin Ken Hang. I will be your second panel for this forum.
Okay, hi guys. My name is Nur Hidayah binti Zafir Effendi and I will be your third panel for this forum.
Before I start, I hope that our panel are in good health and condition and stay safe at home during this pandemic. So I will explain to you guys briefly about introduction for the topic in superconductor. As we know, superconductor are the material having almost zero resistivity and behave as dimagnetic below the superconducting transiting temperature. Without wasting any time, my first question will be go to our first panel, which is Atika Adila. So what can you explain or give me or tell me about what is tunneling effect?
Okay, first of all, my name is Nura Atika Adila. So I will give you guys about information about what is tunneling effect. So basically, before I start, I will introduce you guys about a little bit history about the tunneling effect. Actually, uh, tunneling effect a little bit about how the tunneling effects can be found and be studied. So this is actually happen uh, when the effect was predicted in the earlier 20th century and it accepted as a general physical phenomena come in mid of century. So the quantum tunneling is projected to create the physical limits to the size of transistor used in the microelectronics due to the electron being able to tunnel past transistors that are too small. In earlier 1960, Ivor Gaffer and Brian Josephson were studying in the tunneling involving the superconductor. And because of these two gentlemen, nowadays we can know and have an idea about how this phenomena occur. So before this tunneling effect can be defined as two terms, which is semiconductor and quantum mechanics. So in the semiconductor is a purely quantum mechanical process by which is a microscopic particle can penetrate a potential barrier even when the energy of the incident particle is lower than the height of the barrier. So and the second is for the quantum mechanical effect, which is what we will be focused about. So this tunneling effect is tunneling current that occur when the electron move through a barrier that they classically shouldn't be able to move through. In the classical term, if you don't have enough energy to move over a barrier, so you will ever be passed through the barrier. However, in the quantum mechanical world, these electrons have a wave-like properties. So this wave don't just go to just end at the wall or a barrier, but it will taper off quickly in the barrier. So if we want to overcome this phenomena, so we need a very thin enough barrier so that the probability function may extend into the next region or through the barrier. So because of this small probability of the electron being on the other side of the barrier, the electron have enough energy to pass through to the other side. So this is basically the what is tunneling effect should be. So I'll pass to our moderator.
Okay, thanks to our first panel. From what panel 1 have said, now we know that tunneling occurs when a particle with low kinetic energy is able to pass through a barrier which has a higher potential energy, right? Okay, right. My next question is for panel 2. Chin, what is the working principle of tunneling effect in superconductor? Can you explain?
Hi guys, my name is Chin Ken Hang and I'm going to explain to you guys the working principle of tunneling in the superconductor. So when we talk about the tunneling in superconductor, we usually refer to the Josephson effects. So the Josephson effects is a physical phenomena describing what occur when we have quantum tunneling between the superconductors. So these Josephson effects usually occur at the Josephson junctions. So a Josephson junction is made out of two superconductors separated by a non-superconducting layer that is very thin so that the electrons can cross through the insulating barrier. So the flow of current between the superconductors in the absence of an applied voltage is known as Josephson current, and the movement of electrons across the barrier is known as Josephson tunneling. So according to the BCS theory, superconductivity is a result of correlated motions of the electrons in the superconducting solid. In normal situations, electrons cannot move together due to the repulsive force and they tend to have different quantum state. But in certain circumstances, for example, a phonon is applied to them, two electrons can be combined and form Cooper pairs. When they combine together and forming Cooper pair, the electrons can be moved easily through the barrier. At this time, the Cooper pair in each superconductor have the same quantum state and also the same wave functions. If there is no current flow, one side of Cooper pair can move to the another side of Cooper pairs and link to each other. So I think that's all for the working principle of tunneling a superconductor. Thank you.
Thanks to our second panel, which is Chin, to make or giving a brilliant sharing or explanation. For panel 3, which is Hidayah, what are the application of tunneling effect?
Thank you, Akila. So I will be discuss about the application of tunneling effect. So there is a variety of application, but I picked two to explain to you guys. So the first one, I will be focusing on the specific part which is about tunneling effect itself in these two applications. So the first one will be STM, which is scanning tunneling microscope, and the second one is the tunneling diode. So the first one, what is scanning tunneling microscope? It is an instrument imaging surface at the atomic level. It can investigate and locate a single atom, showing the arrangement state individual atoms in the material surface. So it operates by taking advantage of the relationship between quantum tunneling with distance. When the tip of the STM needle is brought close to a conduction surface that has a voltage bias, measuring the current of electrons that are tunneling between the needle and the surface itself, reveal the distance between the needle and the surface. By using a piezoelectric rod that change in size when voltage is applied to it, the height of the tip can be adjusted to keep the tunneling current constant. The time varying voltage that are applied to this rod can be recorded and used to image the surface of the conductor. So what is piezoelectric effect? The piezoelectric effect is created by squeezing the size of certain crystals such as quartz by or barium titanate. The result is the creation of opposite charges on the sides. The effect can be reversed as well by applying a voltage across a piezoelectric crystal. It will elongate or can be compressed. These materials are used to scan the tip in and scanning tunneling microscope and most other scanning probe technique. So next is tunnel diode. Tunnel diode is used as a very fast switching devices in computers. It is also used in a high frequency oscillator and amplifier. A tunnel diode is a heavily doped PN junction diode in which the electric current decrease and as the voltage increase. So this is the symbol diode as shown as in the picture. So the p-type semiconductor act as anode, which is it will attract electron emits from the n-type, and the n-type itself is will emit or produce electron and act as a cathode. So this is the symbol, and they are usually made from germanium, but can also be made from gallium arsenide, silicon, and gallium antimonide. So the working of tunneling diode is if the impurity concentration of a normal p-n junction is highly increased, the tunnel diode is formed. When the impurity concentration in a diode increase, the width of the depletion region will be decreased, extending some extra force to the charge carries to cross the junction. So when this concentration is further increased due to less width of the depletion region and the increased energy of the charge carrier, they penetrate through the potential barrier instead of climbing over it. So this penetration can be understood as tunneling, and hence the name is tunnel diode. So I think that's all from me.
Okay, thank you for panel 3. So I'm curious, or I have a question. What is the limitation, or does the STM have its own limitation? Okay.
Okay, so for your question, there are several disadvantages of so I will tell you three limitation or disadvantages of using STM. So the first one, of course, STM are usually a highly specialized equipment that is very fragile and expensive. So the next one is STM can be difficult to use effectively. This is because there is a very specific technique that requires a lot of skill and have and we have to be so precise when handling the machine. So the next one is STM require a very stable and clean surface, excellent vibration control, and also a sharp tips. So that's all. The limitation of the STM itself.
Okay, thank you for our panel 3. So actually, there are a lot of explanation or question and answer that we would like to share to you guys today, but it's too lot, or it's a lot, and we don't even have much time, right? So as conclusion from our forum today, what we can say is in quantum mechanics, tunneling effect is particle penetration through the potential barrier, even if particle total energy is less than the barrier height, and the transparency coefficient of the rectangular barrier decrease exponentially with the barrier width when wave vector of both incident and transmitted wave coincide. Yeah, I think that's all from us today. Thank you.
Thank you.
Hello.